Alright, this solution walkthrough for Exam 3 version 1. There's g of x and f of x, and we're going to be giving the solution. I draw this. One thing to recognize to make your life a little easier in the combination parts, actually in the division part mostly, is that x squared minus 9x, do our little magic x, two numbers that multiply to 20 and they add to negative 9. I see that 20 is 1 times 20, 2 times 10, 3 is not a factor, 4 times 5. Oh, if I subtract a minus 4 and a minus 5, then I get negative 9 multiplied together, give me positive 20. So for the help, I know that that's x minus 4 times x minus 5. That is going to help me down here. Otherwise, f plus g of x, well, we simply do the plus vertically here. Well, adding them together, we only have 1x squared around, so I know that there's 1x squared in there. I subtract 9x, and I add 1x. Like terms add together, so that makes it a negative 8x. 20 subtracting 4 gives me 16. So I don't have to show a lot of work there, except that I'm doing the addition vertically. Same thing with subtraction. Change this into a subtract vertically. Well, there's still only 1x squared around, so we leave them balance out. And now we're doing a minus 9x minus another x, so that becomes a minus 10x. And plus 20 minus a negative 4 means I'm adding 4, so that becomes a plus 24. Okay, so that's f minus g. F times g, I need to multiply them out. So I'm going to be multiplying x squared minus 9x minus 20 times x minus 4. Well, I could simply multiply the x by everything. Okay, so it becomes the x times everything in f of x, so it's x cubed, x times x squared, x times 9x, that becomes minus 9x squared, and the x times minus 20, that becomes minus 20x. Now I'm subtracting 4 times all of this, so let's put that as a minus, and then inside the parentheses we'll do the multiply by 4. So there's the minus. Now I'm going to multiply all this by 4, so that becomes a 4x squared. That becomes a minus 36x, and that becomes a minus 8. See, I'm multiplying each of those by 4. That gives me that. Now I can combine the like terms. There's only one x cubed around, so we have an x cubed at the front. There's a minus a 9x squared and a minus another 4x squared, so that becomes a minus 13x squared. Just a second here. And what just happened? Oh, I know what happens. I use my mouse and the X and use the screen at the same time. I'm like, then my PC goes crazy. That's what's going on. These guys got small. Okay. Oh, now back here. So that becomes then a we have our x squared. Now we have a minus a 20x minus a negative 36x. So that becomes a adding a 36, right? A minus of a minus. So that becomes 56x. And well, there's only the minus a negative 80 laying around, so that becomes a plus 80. Now f divided by g, that's where that factoring comes in handy. Since I know x minus 4, x minus 5 is f of x, so I can do x minus 4, x minus 5 times x minus 4, all divided by g of x, which is x minus 4. Minus 4. Someday it will slow down on me. I don't know why. It's getting mixed up whether I'm moving or whether I'm doing a pencil. And x minus 4's factor out, so this simplifies to x minus 5. Now if you didn't recognize that simplification, you could just put f of x over g of x. So f of x over g of x, x squared minus 9x plus 20, all over x minus 4 would also have been taken as a correct answer because it said you do not have to simplify. Okay. Now a couple I'm hoping you'll find pretty easy ones. We have f times g of 1. One thing to remember when you see this, what that means is, that goes a little bit there. Yeah, I accidentally touched that, or the windows get messed up. F times g of 1, well, think of this as f of 1 times g of 1. You gotta recognize that. So all we have to figure out is f of 1. Well, f of 1, here's x of 1, here's f of x, and there we have f of 1 equals 2. G of 1, well, here's the input 1, and what we get out is that point, which is 3. So g of 1 equals 3. And multiplying together, 2 times 3 equals 6. So that's how we get 6 for f of 1 times g of 1. But you have to remember this. This is just something you remember. When you see fg of 1, that's what that means. Similar one, but this time we're adding them together. So this is the same as f of 4 plus g of 4. Okay. Well, f of 4, here's the value, so f of 4 is 0. And over here, we have a 4 here, and then you get the value of 4 out, so g of 4 equals 4. Therefore, f of 4 plus g of 4 equals 0 plus 4 equals 4. And now we're given two f of x and a g of x, and we just need to calculate their values at g of 0 and f of 0. But remember, whatever g of 0 gives me, I need then to calculate f of whatever g of 0 is. So we need to calculate the inside part first. Then we'll put that inside f. So g of 0 is 9 minus 0 equals 9. But now that goes inside of f. So f of 9 is equal to 3 times 9 minus 8, which is 27 minus 8 equals 19. So that's the answer. F of g of 0 is 19. Now the other way around, g of f of 0, well, we need to find out what f of 0 is first. F of 0 is equal to 3 times 0 minus 8 equals negative 8. And now g of negative 8 is equal to 9 minus negative 8 squared. Well, negative 8 squared is 64. So 9 minus 64 equals minus 55. G of f of 0. F of 0 is negative 8. And feed that to g. And now you get minus 55. Now we have a table that we're then going to fill out the values. So, well, we don't have a graph this time. We have a table. So, remember, we need to know what is g of 6, and then we'll put that into f. So g of 6, g of 6, it decides to misbehave on me. G of 6, well, let's see, here's 6. G of 6 gives me 0. Well, since I have 0 as a result of g of 6, well, that means I'm looking now for f of 0, because that's g of 6. F of 0 equals, well, I get to 0. F of 0 gives me 0. G of f of 2. Well, we have to find f of 2 first and then put it inside. F of 2 equals, here's 2 coming in, f of 2 gives me 8. So f of 2 equals 8. So now I'm looking for g of 8. G of 8, because f of 2 now goes inside of g. Because of that, we're looking for g of f of 2. G of 8, here comes 8. Output for g is 5. Put that here. F of 9. Well, let's find out what f of 9 is, working out from the inside out. F of 9 is equal to, well, go up to my table. When I have a 9 coming in, I get out of 6 for f. So f of 9 equals 6. And now, f of 9, well, that's f of 6. And when I get a 6 coming in, I get a 2 for f of 6. G of 8, well, I'm looking for g of 8 first, and g of 8 gives me 5. So g of 8 is g of 5, gives me 5 in, I get a 7 out. Now with these, I'm looking for f plus g at a specific value of negative 3 for these first 4. So let's just figure out f and g at an input value of negative 3. Then we can quickly do the math. So let's just do it up here. F at negative 3 is equal to a negative 3 plus 5. Oh, that's equal to positive 3 plus 5 equals 8. And now g of negative 3 is 2 times negative 3 minus 2. And that equals negative 6 minus 2 equals negative 8. So now knowing f and g at negative 3, f plus g at negative 3 is equal to, well, there we go, 8 plus negative 8 equals 0. F minus g, making sure that I get the f's right, that's the f, and this is g of negative 3. F minus g is 8 minus a negative 8, which gives me 16. F times g at negative 3 is 8 times negative 8 equals negative 64. I go too fast, that's when it seems to start messing up on me. And now f divided by 3 at negative 3 is that's the same as f of negative 3 divided by g of negative 3 equals 8 divided by negative 8. Better simplify that to negative 1. Okay. Now the next two get a little tougher because I'm doing a composition. First, f of g of negative 3. Well, the g of negative 3 I already know is negative 8. So what I'm looking for is f of negative 8. Because g of negative 3 is 8. So this becomes, this part here, I know is equal to negative 8. So now we're looking for f of negative 8. And that's where I have to recalculate. F is negative its input plus 5. So negative 8 plus 5. Well, that becomes 8 plus 5. That becomes 13. And or g of f of negative 3, and that's, I like to write it out, that's g composition f, that's g of f at negative 3. I like that form better. F of negative 3 I know is 8, so that's the same as g of 8. Well, I have to go back to the definition of g, which is 2x minus 2. So g of 8 is 2 times 8 minus 2. 16 minus 2 equals 14. Multiple combos, but this time it's just from a table. So remember, this is the same as f of g of 9. So g of 9, here's the 9, I get negative 7 out. So that's equal to f of negative 7 equals, here's my negative 7 in, I get a 9 out. G of f at negative 3. Well, that's the same as g of f at negative 3 equals, well, f of negative 3 is negative 2. So that's equal to g of negative 2. Negative 2 in, g out, gives me negative 3. F of f at 7. Let's do that over here. That's f of 7. F of 7, 7 in, I get 7 out. 7 in, I get 7 out, equals 7. So f of f at 7 equals 7. When f is 7, I get 7 out. So f of f equals 7. Let me adjust my notes here. Come back, see if I can keep bad things from happening. Do this in the right combination. Okay, last one. G of G at -2. G composition G. G of G at -2. Well, G of -2, -2 in, I get -3 out. So that equals G of -3. -3 in, G of -3 gives me 10. So 10 goes here. Now the inverse. Remember, the approach to the inverse is we first state this as a y and an x. That's the same as y equals 7x plus 2. Swap the x and the y. X equals 7y plus 2. Now solve for y. Subtract 2 from both sides. X minus 2 equals 7y. And now divide by 7 to solve to get y isolated by itself. Y equals x minus 2 divided by 7. So after -1 is x minus 2 divided by 7. Now this one, I have to simply calculate e to the third. When x is 3, that's basically e to the third. Well, I use my calculator, and I'll just bring up my PC calculator here. Bring them over here. I have a standard calculator, and I'm looking for x to the third. Well, it's not on the standard calculator. I have to change him to scientific. And there I have e. There's e, and then I take him to a certain power. So e, x to the y, where y is 3, 20.0855. It said 4 decimal places, right? Oh, 3 decimal places. Oh, 20.086 because that 5 would round up to a 6. So 20.086 if it's 3 decimal places. So, answer would be 20.086. If I'm rounding up to a different number of decimal places, then it would be a different number. Alright, now we're getting another exponential. Here's f of x is some power of x. Oh, don't worry, all we do is wherever we see an x, replace it with a 2. So f of 2 is equal to 5 to the power of, and just to make it clear, I'm going to put all that power in parentheses. So 5 to the 2 times 2 minus 1, or 5 to the 4 minus 1 equals 5 to the third. Well, that one I can do in my head. 5 times 5 times 5. 25 times 5 is 125. Well, if I'm increasing x by 1, oh, but I'm multiplying by 2, so let's put that in there. 5 to the 2 times 3 minus 1 equals 5 to the 5th. Now that one I'm not quite ready to do in my head, so I'll do it in my calculator. I'll do 5 x to the 5th, enter 31.25. Now this one, we just use our interest formula. And remember, our interest formula, the result of our investment, A, is equal to the initial investment, P, times 1 plus my rate of investment in decimal. Remember that, converting percent to decimal. Divided by the number of times per year it's compounded to the n times the number of years. Well, let's plug in our numbers. P is 4,000. 1 plus the rate. This is where you have to be careful. 4.5% is equal to 0.045. Now, semi-annually means that's 2 times a year to the power of 2. And how many years? 7 years. So we'll put 14 there. We'll put that all in our calculator. So we're going to multiply times, or 4,000 times in parentheses, 1 plus 0.05, 45 divided by 2. Take that to the 14th power. Well, for my calculator, I'm going to start here and then take that to the 14th power. Then I'll multiply by 4,000, just to make it simpler on my calculator. So I'll take 1 plus 0.045 divided by 2. Come on, Mr. Calculator. I'm going to move that so I can see my formula at the same time. Well, I guess I can. So I'm going to do 1 plus 0.045 divided by 2 equals, there's the 1 plus a small number, x to the y, 14. And now multiply that by 4,000 times 4,000. 5461.93. 2 decimals is standard accounting. 5461.93. So I'll put in the answer from my calculator. 5461.93. Now all we need to do with this is put it in log format or exponential format. Remember, what I'm looking for is 2 to what power, or sorry, n to what power gives me a. Remember, it's n to that power gives me that. So n to the b equals a. N to the b equals a. Whenever you see this, one way to remember is just remember that log of 100 equals 2. And without a number there, we know it's 10. That means 10 to the second equals 100. That's a good formula to remember. Or remember the spiral thing. N to the b is what's inside of there. So n to the b equals a is the answer. N to the b equals a. Same thing, but going the other way. So remember, And write that down again. Log a base A of x equals y is the same as A to the y equals x. A to the y equals x. When you see that, well, if we have it this way, that means log base g to the a equals w. Well, that would mean log base g to the a equals w. G to the a equals w. Therefore, when I see g to the a equals w, that goes back logarithm log base g. Sorry, that's not a g, it's a 9. Log base 9 to the a equals w. 9 to the a equals w. So just get those equations together. You remember the little spirally thing? Log base a of x equals y. A to the y equals x. They're equivalent statements. Now we have the product rule. There's two possible answers. Some recognize log of 4 base 4. We know that that's 1, which is, I thought, well, rather a good observation. And log plus log base 4 of z. I would take that as a correct answer. But another way to look at it is using the product rule. That's also the same as log base 4 of 4 times z. Log base 4 of 4z. The product rule means you add the logs of the numbers being multiplied. But if you recognize log base 4 of 4 being 1, I thought that's a good thought, and it's true. Okay, so now log base 5 of b to the negative 4, you can recognize the same thing when the powers multiply out in front of things when you're doing logs. So that's the same as negative 4 log base 5 of b. That's all they're looking for. And then they just get a little more complicated. We're looking for a combination of both product rule and exponent rule. You want to break it apart in pieces here. 5 log 4 of z is the same as log base 4 of z to the 5th. Well, this doesn't simplify to any exponents, but we are adding them together, so that's the same as multiplying 6 and z to the 5th. So that becomes the same as log base 4 of 6 z to the 5th. Product rule and exponent rule. And we just get a little bit more here. We need to break that apart, going the opposite direction. Well, let's do the product rule first. Log 4 of w to the 20th plus log 4 of z to the 3rd. And then using the exponent rule, 20 comes out to the front of the log. That becomes 20 log 4 of w plus 3 log base 4 of z. No more needed. That's the simplified. And one more that does a little division rule in exponents. I'll decide to go small on me. Yeah. Remember division, I'm subtracting. There are no exponents to worry about, but we do the division rule first. That becomes log 3z minus log of 9. Well, log 3z can be broken up into log of 3 plus log of z. So we break this part up. And I would accept you doing this all in one step. Log 3 plus log of z minus log of 9. Product rule, division rule. Log 3 plus log z minus log 9. And that is it for that review.